I think this is also like kind of a geometry question. So in this question, we have Spot's doghouse has a regular hexagonal base that measures 1 yard on each side. And we're given that he is tethered to a vertex with a 2-yard rope. And we want to know what is the area in square yards of the region outside of the doghouse that Spot can reach. So again, this is like kind of like a different kind of geometry problem. So first we draw like this dog's like doghouse. Like it's gonna be a hexagon, since that's what we're given. It's a regular hexagon. And we're given that he is like tethered to a vertex with a 2-yard rope. So let's say like Spot is like right here, like and he's tethered to a rope of length 2 yards. So we want to know like what is the region he can reach, right? So the idea is like if the hexagon wasn't here, like then Spot can just like go to any point inside the circle of radius 2, right? Like Spot can like reach any point inside the circle of radius 2, but in this case we have the hexagon, right? Like so that's gonna like disrupt some stuff. So basically like we have to like be more careful then. So the idea is like notice that like we know that the side length of the hexagon is 1, right? So Spot, like the dog, can like reach like any point. Like if you were to like kind of like draw a circle of radius 2, like if I were to draw this length here, like if I were to continue this, then like if I were to draw this like kind of like a portion of the circle, like clearly we know Spot, like where like any of these lengths, they're all like equal to 2, right? Like this is just kind of like a sector of the circle. Then like Spot can reach like any like point inside this like red region, right? Like that should be pretty obvious, right? Because like this is just like a sector, like a portion of a circle of radius 2. So Spot can like reach any point inside this like red area here. Notice that like Spot like if Spot is like wants to reach like some of the blue points, some of the blue region here, notice that like if Spot is like standing here, right? So like let's say Spot is like standing at this green point here. So currently the rope is like 1 yard long. So he still has 1 yard to like spare. So at this green point, like Spot can like can go like any point that is within a distance of 1. So like that would represent like this like green sector in this case, which also represents like the region that Spot can go to. So like this green sector would also represent it. And this would like represent like all the possible like places that like the dog can go, right? So the red region is like the red region you can think of as like the places the dog can go, as if like the hexagon didn't exist. Like if we pretend we ignore the hexagon, then like it would be this red region here the dog can go to. And then let's say the dog wants to get to like this like left hemisphere of the plane, then the dog is gonna have to like make the rope touch the doghouse, like in this case the green rope. And then since the side length of the hexagon is 1 and the rope has length 2, that means that the dog still has like a 1 yard length that it can travel, and that represents this green sector of radius 1. And then to like find the answer, we can just compute the area, right? So we know this angle here, that angle is 120 degrees, right? Because we know that each angle in a regular hexagon is 120 degrees. And that tells us that this angle here, this big angle, has to be equal to 240 degrees then. And we know that the radius is 2. So the area of the entire red circle would be 4 pi, but we're taking a section of it. So 240 over 360. So that would give us like 8 pi over 3. So 8 pi over 3 represents like the red region in that case. And then the green region, would be like it has a radius 1, and we know that like this has 120 degrees, so this angle here is 60 degrees. So then the area of each of these green sectors would be like, so the area of the entire circle would be pi, But since we're only taking a 60-degree angle, the area of each of these green sectors is pi over 6. And since we have 2 of them, we double it, and we get the total area of the green sectors is pi over 3. So the total area that spot can reach is going to just be like 8 pi over 3 plus pi over 3. And that would give like 3 pi. And that would like correspond to like choice E, which is the right answer. Like, so yeah, this is definitely like a really common kind of question where it's like you'll basically see like the same question like many times, like probably in a few, or maybe not the same, but like very similar, where it's like, suppose you got this, and it's like this dog or something that's like tied to this pole, or like tied to this doghouse here, and we want to know like what is the area of the region, like that this dog can reach or something like that. Another common like variation or type of question would be like, suppose like a person is walking down the street, and from any like point they can see like 1 mile away, or I don't know, something like that. You want to know what is the area of the set of all the points that the person can see, or something like that. It's a very common kind of question where like questions like these where you have like something that's like that is restricted to some like length, and you want to find the area of some locus of points. It's like a very like difficult kind of question, I guess.